energy density in electrostatic fields. Suppose we are transferring three charges from infinity to point P1, P2 and P3 respectively. That is, this is infinity and transferring charge Q1 from infinity to point P1. Second, charge Q2 point P2, and third one, charge Q3 and point P3. Now, total work done. Now, total work done will be equal to WE is equal to W1 plus W2 plus W3, because during W1 system will be at rest, or we can say initial value is there, so at rest work done will be 0, and for W2 it will be equal to Q2 into V21, because we know in previous lecture I have seen W is equal to Q of VAB, or we can say Q into VB minus VA. Okay, so Q2 into VAB. Okay, for W3 it will be equal to Q3 plus V32. Suppose this is equation number 1. Now I am changing the sequence, and it is starting from in reverse. Infinity, this is Q3 point P1, this is Q2, this is point P3, this is P2, and this is Q1, this is point P1. Same situation, it is some space. Now resting condition will be at Q3. Okay, so total work done or total potential energy will be W is equal to W3 plus W2 plus W1, and during W3 it will be equal to 0 plus W2 Q2 into V23 plus Q1 V12 plus V13, and this is equation number 2. Assuming adding equation 1 and 2, adding equation number 1 and 2, we get 2WE is equal to Q1 V12 plus V13 plus Q2 V21 plus V23 plus Q3 V31 plus V32. Now 2WE is equal to Q1 into V1 plus Q2 into V2 plus Q3 into V3, where V1, V2, V3 are total potentials. at point P1, P2 and P3 respectively. In general, if there are n point charges, equation suppose this is equation number 3. Equation 3 becomes it will be equal to WE is equal to 1 by 2 summation K is equal to 1 to N QK into PK. Okay. Now if instead of point charges, the region has a continuous charge distribution, the summation becomes, this is the condition, if the region has a continuous charge distribution, then in this case summation will be integration. So W is equal to 1 by 2 integral V rho V into V into dV. And this is the case for volume charge. This is the case for volume charge. Right? Summation is summation has been changed into integration. Okay. And Q is equal to charge is equal to integration rho V into dV. Okay. So rho V into dV, and uh, this potential is written here. Now we know using Gauss law rho V is equal to del dot D. Okay. W is equal to 1 by 2 del dot D into V into dV. We know vector identity del dot VA, where V is a scalar and A is the vector, is equal to A dot del V plus V del dot A. And using this equation, we can write del dot A V is equal to del VA minus A del V. Okay. Now W is equal to 1 by 2 del dot VD vector into dV minus 1 by 2 V d del V into dV. Okay. Now by applying divergence theorem divergence theorem using divergence theorem we get W is equal to 1 by 2 VD vector dot ds vector, because divergence converts closed surface integral into volume integral. Now we are reversing the process. Volume integral converts into closed surface integration, and this is the circulation. Minus 1 by 2 V d dot d del V into dV. We know potential V is proportional to 1 by R in the EMFT, and D is proportional to 1 by R square for point charges. For point charges. Now, for dipole cases, V is proportional to 1 by square potential and D is proportional to 1 by R cube for dipole case. For dipoles. Now, VD vector must be proportional to 1 by R cube, 4-point charge, 4-point charges. So, but ds is proportional to r square, because we know ds in spherical coordinate system, ds is equal to r square sine theta dr d theta d phi. Okay. Now vd vector dot ds vector must be proportional to 1 by r. Okay, because we can cancel 1 by r cube into r square, then we get 1 by r. We can cancel r square power. Now in integration vd vector ds vector, if the surface is very large, then r increases. If surface becomes large, it means r becomes high and it becomes 0, because if r increases, then this value decreases. So if r infinity, then it becomes 0. So we is equal to minus of 1 by 2 v d dot del v into dv. Now it becomes, because we know E is equal to minus of del v, so it becomes w is equal to 1 by 2 d dot E into dv. Okay, and we know d is equal to epsilon E, and we get w is equal to 1 by 2 epsilon E square into dv. Okay, or w is equal to 1 by 2 epsilon E square into dv, and this is energy charge density. Energy density, and this is electrostatic energy density, we, small we, and this is an unit of small we, joule per meter cube. So small we is equal to 1 by 2 epsilon E square. It may write d square upon 2 epsilon. Okay, and unit of small w is joule per meter cube. For free space, epsilon must be equal to epsilon. Thank you.